Good day, everyone. Good day, everyone. I'll start sharing my screen soon. Please, my screen visible. My screen is visible. Okay, so today we'll just be talking about how to run a pipeline on Kubeflow, and we'll just be just running a sample pipeline here. So I hope we're able to install Kubeflow pipeline in our local. Um, so yeah, so let's go. Let's start. So let me share my screen. All right, so today I'll just be talking about how to run a simple pipeline. We'll just be training the on an XGBoost model. Then we'll just be running the whole ML pipeline here, right? We call it the XGBoost pipeline. So we'll be um we'll be running through all the components that make up the pipeline and how we can push it to the UI and get this kind of interface there. So um, let's go. Let's start. So the first thing is that you need to have installed and set up KFP. That's the SDK for Kubeflow pipeline, right? To communicate with Kubeflow pipeline. And yeah, you should have the conda environment set up too, right? So you can, because the environment might clash with another environment, another package, right? So you just create like set up my mini conda. If you have Anaconda that works, then create a conda environment, right? Maybe name it anything you want to name it. Then just pip install AFP, right? So depending on the version of Kubeflow pipeline you're using, you can install the corresponding Kubeflow SDK, sorry, Kubeflow pipeline SDK, right? So I installed because I set up Kubeflow pipeline version 1. I will use the SDK version 1 too, right? So okay. All right, let's go. So today I will be talking about the components that make up this pipeline, right? So you can see from here, I created the components from a file, 4 of them, right? And each of these components means something. Right? So I'll be going through all their YAML files, right? For this taxi data set operation, right? I created a YAML file, right? And the name of the component is Chicago taxi trip data set, right? So what this is doing, the whole pipeline is we are going to get data set, we're going to train a model, and we're going to make predictions with that model, right? And to do that on Kubeflow, you have a lot of different ways to do that. And for this, we're going to use Coil. If you are familiar with Linux commands, you can use Coil to download a whole lot of things. You're going to download tables, you're going to download CSVs, you're going to download images. Right. So what we're going to do is we're going to use Coil to download a CSV, right, from Chicago City, right? It's about the taxi trips, right? So we're going to be using that to make a prediction on the tips that will be given to the taxi drivers. That's what we're making our predictions on. And these are all we're doing is we're selecting data from 1900 to this year, right? That is to latest, right? And we're going to limit it to 1,000 rules, randomly sampled 1,000 rows, because this is actually this is a CQ table, right? It's a database. This site there's a database here. In that database, you want to select, if you are familiar with CQ, you know that you can use the limit command to limit how many rows you want to select. So I want to select some particular column names, and I'm going to convert it to a CSV. Right? And we're going to output it to a table. Right? That will be an artifact. And so this is the actual container. Remember the implementation. You in Kubeflow, you work with Docker or just Python functions, right? Lightweight Python functions. But in some cases, for reproducibility, right? You package the Python function into a Docker container, right? And so inside that Docker container, you can now run the commands there. Right? So this is already a Docker container that's out there. Or running a command on it, right? So this is the command. We are setting environment variables, we're making a directory, then we're downloading all of the data into that directory. Right? This is the format of a component YAML file. I give it the inputs, right? Specify the outputs, put that into your image environment variables by using this, right? Just this you giving the arguments for the core. So this select is going to be set as an environment variable select, right? These placeholders are just, this is for the first argument, second argument, third, and fourth. So these are placeholders. I'm going to set environment variables, all of them. And so it's going to download all of that, and that's just one component of pipeline. Second component is converting a CSV file to Apache package. Now, if you're familiar with package, you know that packages are more lightweight and they're not very large as CSV, right? They are more compact and right and it's faster, right? Faster to load, faster to read. Just that you can't see what is inside a package file or like CSV. Right? So to do that, we're going to use a Python command. And so we're going to use a Python file, right? So these are now component, convert CSV to Apache package. Right? This is the description. And what we're going to use as input is the CSV that we downloaded here. Right? We'll pass it into it using a pipeline command. And okay, so sorry about that. We're going to input the input of this component is CSV, right? And output is a package file, right? Output data in a package file. And so what we're using for this is a simple Docker image Python 3. Remember, in Docker Hub, you can download a whole lot of different images that you want, right? You can download whatever image, and there's a particular image for Python 3.7 called Python 3.7. And remember, there's Python, latest version is Python 3.11. So if you just search on Docker Hub for Python, right, it's a standard Docker image, and you can pull whatever Python version you want from 3.8 even to 3.7, all of that. So we're just going to pull that. We're going to run some commands on it, right? Pip install, right? Pip install PyArrow, because PyArrow is a package that helps us convert um, file types, right? I think it can take a whole lot of different file types, not just package, right? So we're going to install PyArrow. So we're now, after doing that installation in the Docker image, right? You could have so I've created a Docker file specially for this, right? And in that Docker file, I put all of this pip installed and whatnot inside, right? But this is just faster, right? This is just faster to run from the component itself. And now after running that we can now call Python 3 because in a Docker image, we have Python 3.7 installed. So to run a Python, remember to run a Python command, just write Python 3 and that file. And because we're running it in just one file, we're just concatenating all of the scripts together, right? So we are concatenating all of that, the functions we want to use. Then we call the function, right? We're calling a function with, remember, let me just go through this. This is a function to make a directory. This is a real function we're using here. It's going to get a data path and output data path. So it's going to read in the CSV and write it into a package file, right? And we're going to, in the whole, if you can just imagine, in the whole, imagine this is a file, we're not going to use argparse, right, to specify arguments we want to put into the file. If you work with argparse, you know that argparse helps you. If you want to run a Python script, you can use argparse to pass arguments to that Python script itself. So that's what argparse will help you do. And we're specifying the from with argparse the data and the output data parts, and all of that. We're now going to run the file itself, and we're passing. Remember, there's inputs and there's outputs in the actual components, and the input to this component is the output of this one, the table, right? The outputs, right? So that's the input, and the outputs will now be a package file. And this is, like I said, I'm just recapping that this is the whole script that we run to convert that CSV to a package file, right? And so let me go back to the component, sorry, the pipeline. Look at it here. This is the pipeline, the first one we just look at downloading data. Downloading data, we specified some arguments here where we want data to be downloaded from 2019 to 2019. We selected some particular columns we want, and we limited it to 10,000 rows, right? And we are getting the output of that, right? This dot output is like a method to take out the output, right? And this is going to be set to train data CSV. And this is now the input to this component, convert CSV to Apache operation, to Apache packet operation. And this is now the input to this method, to this function, right? Or this component, right? And there's now an output, training data packet. And that will now be the input to the actual XGBoost training operation. So let's go to the XGBoost train operation to see. So there's now a component, right? So the whole thing is that you can specify the component in this same file, right, with Python script, or you could have done that in separate files where you're importing all of them, right? We're importing all of them with load component from file. We're importing all of those components. That's what we're doing. So I've already compiled all of the components into a folder, and I'm just importing from there. So in this XGBoost, there's the predict component and the train component. So for the train component, we're going to look at it. What is it doing? Right. So it's the same thing. Name is XGBoost train. It's going to train an XGBoost model with some arguments, right? And we're specifying the input we want to these components, right? The training data, the columns we want as a target column, the model we're using, and we also specified optional, like it's optional, and there are some default parameters, right? So the number of iterations is optional, right? And the default is 10. Booster params. These are all this for data science guys. This for the data scientists, right? This might not be concerned with you except you want to be concerned with it, right? These are all parameters for HDBoost mode, just like your linear regression model had parameters, right? This is the data scientist work. Your work is to just take in the scripts and convert it to this YAML component file, right? That's your job, right? Take all of that, put it into a component file. You can always work with the data scientist to do that, right? And you are the one that will be in charge of the containers and the versioning and everything, right? So this is the actual training script. This is training scripts, and this is the arguments to the training, the parameters to the training function. This is the training side, right? The XGBoost, and this is the training. This is where the training begins. The XGBoost.train. Then we now save the model to the model parts that was specified in the arguments. We save that and we write that. We also write the config to some parts too, right? The configurations of the model, right? And remember, for us to be able to pass arguments to it, we have to use argpass. That's why we're using argpass, so we can be able to pass arguments in the components, right? Through these inputs and tags, right? And we now specify the arguments in the Docker image, the ones we want, right? If they are all there, right? These are all if conditions, right? If they are present in the pipeline here, and this is for the training. And also in the pipeline, there's now the predictions. While we're passing the training, we're also predicting the same training data just for easy, just to make it easy, right? And remember, we're passing the model we trained on. After training, we make predictions now. So we're passing the model we trained on. We're selecting the model. Remember, there are two arguments, there are two outputs in this component, the model and the model config. So we're selecting only the model, right? That's what we're doing here. We're selecting only the model because there are two outputs. We're selecting the model, we're passing that into the predict, which will be used to make the predictions, right? On the data, the training data, right? And this is the whole pipeline. This is like a pipeline, just a workflow from getting data to doing the pre-processing to training to making your prediction. That's the whole ML workflow, right? And this is what we made with this function. And remember, we have to add a decorator, a pipeline decorator, giving it a name and the other optional arguments like description. Pipeline route is just for if you want your pipeline routes just specifies, are you working with a different storage and what are the permissions you want us to use for the different storage? Like for this case, this person, if you want to use the Google Cloud Storage to host any of your artifacts, you can specify that here, right? So we have the whole pipeline. We have the components that make up the pipeline. We're now going to have to compile a pipeline, right? So we can put it into the UI here, can upload it into the UI, right? And to do that, we have to run the KFP compiler method, specifying the pipeline function, XGBoost pipeline, and the YAML file you want it to output, that's pipeline.yaml, right? And I'm hoping that we have already set up the local deployments, which I showed you in the last class, right? The local deployments. And on my end, I have the deployments running, right? Or everything, the Kubeflow pipeline running and our port forwarded, right? Everything is running up to date. I can confirm that for you with kubectl get ports flow namespace, right? I will see everything is running. We have everything running. Before I already tested the pipelines and we see that it's completed. I also tested out the XGBoost pipeline. I actually got an error before, but I was able to resolve that. So this XGBoost pipeline, we'll get to that. So we have the ML pipeline, everything running complete, right? And I port forwarded and I've been able to access it from my user, from my browser, right? And so what's next? Since we have a pipeline, we have all the components joined together to make the pipeline. It's time for us to compile the pipeline. And to do that, remember I told you that you should have your Conda environment running, right? This environment I'm using is it's ML pipeline. Let me just do that for you. Conda environment list. Okay, this is going to work. Yeah. So there's the base environment and there's the ML pipeline I created for this use case. And I have, I think, Conda, um, Conda list environment. I have KFP with, I just want to be sure that I know, sorry, Conda. I want to be sure that I have installed KFP. Okay, you're right. So I want to be sure I've installed KFP into this, and we can see that we have KFP for version 1.8.0, right? I I reinstalled the new Kubeflow pipeline version 1, right? Just for this case, right? And I'm installing the appropriate KFP SDK, right? To interact with that Kubeflow pipeline. And these are all the packages that need to be installed with the KFP, right? So the essence of an environment is that you don't want, like, there might be some cases where, like, because I had an error too with one of these when one of the requests, this request two belts, I had to downgrade it because it was already request two belts is already in version 1.0, but this version of KFP needs it to be at 0.1, 0.10.1. So that's why you need an environment, because at a particular environment in a particular application, you might need the latest versions of some things, but in some other cases, you don't need the latest version, you need a lesser version. That's why you don't want those clashes. That's why you have to use Conda environments or virtual environments like PNV and PyEnv and PPEnv, right? So if I want to compile this, I just have to run Python 3, git that Kubeflow, sorry, is that pipelines, xgboost.py. So what this is going to do, when I run it, right, I've already run it before, it's going to compile all of this into a YAML file. And what I just need to do is to get that YAML file from here. This is the YAML file. So what it does is that it converts all of those components with and pipelines into a YAML file, right? That is understandable by Kubeflow pipeline with all of the and arguments and required settings, right, for it to run. So this is the whole YAML file, and what you just need to do is to upload that into here. You specify the name. I've already uploaded that. You give it a name, give it a description if you want to. You can now upload the file, choose file, because I've already done all of this before. Choose the file, right? And when you choose the file, you can now upload it. That's when you've uploaded it, you'll be able to see something like this here. I give it the name pipeline, right? And so this is the graph you see where you remember we downloaded the data set, passed it on to the convert CSV to Apache package function, which will now convert it to Apache package, which is now used for training, which use the data set for training. And also that model we used, we pass it for predictions with the data set we want to make prediction on. So this just gives a visual, like a visual effect of what is actually going on in the whole pipeline, right? So now for you to run, just create an experiment, then you create an experience, you cannot create a run. And I don't want to run all of that again because I've already done that. So after creating a run, you see that the tag is running. This is a field one. This is one I've filled before. And so you see that a tag is running, right? So not a tag, a pipeline is running. And in the pipeline, you'll be able to see logs of what has been done, right? And you'll be able to see outputs. This is the outputs. Remember, we had the table, and we have a log to log of what has been happening back, right? The downloading and everything, right? So you have details of what components took 8 minutes to run, right? Why is it 3 minutes? So this particular component took 8 minutes to run. I don't want to spend much of our time waiting for something to run. Right? So it took 8 minutes to run, and all of the logs, like what happened in the pod, is shown here. Right? This is what is in the pod description, and this is also the events that occurred, and the all of the metadata, right? All of the logs and the artifacts are going to be shown here. So if you go on to artifacts, because in your pipeline, there's something called artifacts, right? In the artifact, you're able to see all of the artifacts as in all of the model data sets and the model data set that was used in all of the pipeline process. You see here, we have the Apache package. We can also download that if you want to from here. You can just like click on it, output data. You can download that from here. I don't know why it's not showing. Or if you go to this URI, most likely it's downloadable. And we can also see all of the other artifacts that were created in the pipeline. So let me just go back to the run. I hope I've not lost anybody in all of this. I try my best to make it like as simple as possible. So we can also go to this, see all of the output. Like I said, you cannot look at what is in the package file because it's not in a human readable format. This is CSV. This was the input, right? It's CSV, and this is now the output of that converting to package, and you can't really understand what's here. And because of a lot of the encoding that needs to be done to get it to be in a smaller shape or size. So if I click on that, you see that it's just 94.1 kilobyte. But if I open that, you can see 112.7 kilobyte. But if I try to download that CSV, let's see how the size would be. So we see it's 390. And if it was like in a scale of maybe let's say gigabytes, you see that it's also, you see like a whole lot of difference, right? In most of the cases, most times, if you don't want to visually inspect your data, like you can also use the package because it's small in size and very, very fast to load compared to the CSV. So in here we see the XGBoost training, this is the model, and this is the model config and the logs, right? And they are all stored for you to look at for your own like inspection, make sure everything went fine. We have the logs, we have the metadata too with all of the inputs, the properties you set, right? The parameters you set and the artifacts that were produced. So this is also the predicts where the made predictions on some of the data, right? This is where it's going to be stored to in the artifact hashtag 22. So this is everything. I hope like this wasn't like this is not looking like a big deal. It's something that we can all do in our in our own like on our local. Right? This is something that's very, very easy to do. So I will encourage you like to like go online, or I'll also share these files with you, and I hope that you can replicate all of this on your own end. So if there are any questions, I'll be able to take the questions for now. Okay, so it looks like there are no questions. So what I'll do is that I'll share the file with Hamuye, or I will just put this to GitHub and share the link with you so you can look at it in your own end. You most likely have to edit some things like this, right? You most likely have to edit it because this is for my own computer, right? You're not Azure user, right? You have to edit it, but that would most likely be all of the editing you need to edit. Yeah. All right. So thank you all for being here. This was a short session. Hope to be. So since there are no questions, I'll take my leave.